Okay, so how are we doing with Unit 1 so far? I know there's a lot of terms, a lot of details. So we're going to talk about 1-5 angle relationships. So a couple things to be aware of is one, adjacent angles. So adjacent literally just means next to. Okay, so adjacent literally means next to. So two angles are adjacent angles if and only if. Okay, so that's a statement that we've seen before, or that we will see more and more. If they share a common side and have no interior points in common. Okay, so a little example of what we're talking about here is if I have something like this. So those two are an angle, those two are an angle. So if I call that 1 and call that 2, I would say 1 and 2 are adjacent. Okay, they share a side. They share this side, this part that just kind of got darkened right there. And they have no interior points in common. They're not overlapping at all. So that's kind of what we've got. So linear pair I spoke a little bit about in the previous section. Linear pair is basically two things. One, they are adjacent angles. And two, together they make a line. Okay, so I would say angle ABC and angle DBC. They're definitely adjacent. And make a line. And this one's easy to misconstrue because I could have them in a different situation. I could have something like this. These two would still be considered a linear pair. I could have something like this, and these two would still be considered a linear pair. Vertical angles look like this. Okay, so basically vertical angles are when two lines intersect, you have two sets of vertical angles. So you have this angle and this angle. These two are going to be congruent. And then you have these two here, the top and bottom. So they're going to be the non-adjacent angles. So the angles away from each other. Okay, so the angles away from each other, and they're going to be congruent. Okay, so these two angles are always going to be congruent. These two angles are always going to be congruent. Okay, these are big ideas. Okay, a linear pair and vertical angles. So you got to remember that this is going to add up to 180 degrees, and that these are going to be congruent. These show up quite a bit. So you need to make sure that you're familiar with them. Okay? All right, so two ideas for angles that are complementary, add up to 90 degrees. Supplementary, add up to 180 degrees. Okay, so two angles are complementary if and only if the sum of their measures is 90 degrees. One angle is called the complement to the other. Now notice how this is spelled. Okay, notice how this is spelled. This is not the complementary that you might be used to. It's not this. Okay, complementary is when you say something nice. Okay, say something nice. Okay, it's not that. Okay, we're not saying something nice about the angles. We're saying, hey, these two angles add up to 90 degrees. So if I say, well, that's a poor example. So if I say that this is a 30 degrees, and I say this is 60 degrees, well, 30 plus 60 equals 90. So if we look down here at the chart, so this is supposed to be complement, not complement. So a 25 degree angle So the complement would then be 65 degrees. Okay, so you take 90 minus the 25. So the supplement would be 180 minus 25. So that would just be 155. So for 87 degrees, just be 90 minus 87 for 3 degrees. This one would be 180 minus 87. So it's just going to be 93 degrees. So for 134, you can't take 90 minus 134. That doesn't work. So there's none. That one doesn't work. There's no complement there. But I can take 180 minus 134, and that's fine. That'll just be 46 degrees. 8 degrees, and you start to kind of see the idea of what's a complement and what's not. So 90 minus 90 is my complement would be 0. So my complement would be none. And here my complement would just be 90. Okay, so again, it's not the nice complementary and it's not the nice supplementary. The dumb way that I remember this, and it really is kind of dumb, is that, what comes first in the alphabet? Okay, C, okay, then a whole bunch of letters then a whole bunch of letters later, you see S. Okay, numbers. You see 90, then a whole bunch of numbers later, you see 180. So C shows up first, 90 shows up first, complementary. S shows up later, 180 shows up later, that makes it supplementary. So if we take a look, as we're kind of going through here, so they're asking for vertical angles. Okay, so vertical angles are what happens when they're across from each other. So you'll see, so if I look, I can consider VXZ, and then I would look at WXY. I looked at these, VXZ, WXY. Those are vertical. How many pairs of vertical angles are in this diagram? Well, we have these two, which is one pair. And then we have these two, which is the second pair. So there's two. So then, two angles that form a linear pair. Well, there's a whole bunch of those. A lot can happen. A lot happens when two lines intersect. So if I look, I can just take this right here, and I'll take these two. So I'll take angle ZXY. All right, let me do a little bit of erasing here. So I'll take ZXY, and I'll take WXY. That's that one. These two together, they make a line. They make 180 degrees. So that would work. I could take those two work. I could take those two. I could take those two. I could take those two. Basically, any two angles that are not vertical angles, I could take for a linear pair. So let's consider what we've got here. Degree measure of an angle is 3 times the measure of its supplement. Okay, supplement's a big word there. Supplement's a big word. Remember, supplement's going to be 180 degrees. Okay, so I've got two angles that add to 180 degrees. So what do I know about those two angles? Well, I know that one is going to be 3 times bigger than the other. Okay, so if I, just have X, then the other one's going to be 3 times X, and together that's going to add up to 180 degrees. So that's 4X divided by 4. So that's going to be just a simple little algebra problem, just stuff you've seen before. So that's going to be 45 degrees. Okay, so that's that angle. But they want both. So I've got 45 Then I can take 3 times 45. Okay, and that'll be 135. And those two angles, do they add up to 180? They do. And we're done. So now we're changing gears. So now let's look at complementary. So complementary, remember, adds up to 90. All right, so the degree measure of one of the two complementary angles is 6 more than twice the other. So again, you have two angles. All right, so you have your angle, call it y. Then you need 6 more than, which usually means like you're adding 6. And then twice, which means you're multiplying by 2. So I'm going to need twice y plus 6 equals 90. So there's my first angle, there's my second angle. Now it just becomes an algebra problem. Okay, so now you're doing some maneuvering, you're doing some subtracting and whatnot. And you've done just many, many times. So divide by 3. So that will be 28. So one angle is 28. The other angle is going to be 62. Yeah, those will be my angles. One is going to be 6 more than twice the other. So, 28 times 2 is going to be 56 plus 6 is 62, which is what I want. So now, let's take a look at what we got. It looks like we're going to be dealing with some either vertical or linear pair stuff. So if I look at 2 and 4, okay, so 2's right here, 4's right here. So those appear to be vertical. Okay, so if they're vertical, then these two things are going to be equal to each other. Okay, angle 2 and angle 4 are vertical. i.e., that means that they are congruent. So 2x subtract 40, a little division by 2, and so x is going to be 40. And that's all they want. They just want to find x. They're not trying to ask us to do a whole bunch. Okay. So now let's look over here. So now we have 1 and 4. Well, 1's right here, 4's right here. These two aren't equal. They make a line. Okay, so these two are they're supplementary. Okay, they're going to add up to 180. So I'm going to take 3x plus 10 plus x minus 30 equals 180. All right, so those two together, okay, they're a linear pair. So that means I set them equal to 180. So that makes 4x plus 10 minus 30 is going to be minus 20. So this is algebra. I mean, this is not brain breaking at all. So x is 50. Okay, but we're not done. They want you to figure out angle 3. Well, angle 3 right here. Angle 3 is across from angle 1. So that means it's going to be equal to angle 1. So if I figure out angle 1, I figure out angle 3. Okay, so I know that angle 1 is congruent to angle 3, has the same measure. So I'm going to figure out what angle 1 is. So 50 times 3 is 150 plus 10 is 160. There's my answer. So it's 160. I know it doesn't look 160, so you have to kind of forgive that, but that's what you're looking at. Just a few more, so let's take a look. So now you look here and you see this little box. Okay, that tells you that that's 90 degrees. That tells you that that is a right angle. Okay, that tells you that that is a right angle. So 5 and 6 together are going to be complementary. So I'm going to say 3x plus 2x minus 15 equals 90. Okay, what do they want to know? They want to know, find the measure of 5 and 6. So together, that's 5x minus 15 equals 90. 5x equals, let's see, that's going to be 105. Add 15 to both sides. Divide by 5. So x equals 21. So now the measure of angle 5 is 3 times x. So that's 3 times 21. That's 63. So the measure of angle 6 then is going to be 2x minus 15. It's going to be 2 times 21 minus 15. 42 minus 15. So that should be 27. So there's my answers. There's my answers. I know they were complementary. Then it becomes just some algebra, and you're working. Okay, so perpendicular. Perpendicular means a couple different things. Okay, perpendicular is very specific. It says two lines are perpendicular if and only if the lines form right angles. And the symbol for perpendicular lines is an upside down T, like that. And the perpendicular lines form two right angles. And the perpendicular lines, so if I have two perpendicular lines, okay, now let's back up here. Let's not get into that quite yet. Let's talk about this idea. So these two are perpendicular, okay? That means they are both 90 degrees, okay? And they are adjacent. Okay, they share a side. They're also a linear pair. Perpendicular lines are like a very, very specific type of linear pair, okay? So here's the symbol, two right angles and two adjacent right angles. So find x and y so that PR and SQ are perpendicular. Okay, so PR is here, SQ is here. Figure out x and y so that they are perpendicular. Well, perpendicular, if they're perpendicular, then there's 90-degree angles all the way around here. So I'm going to take 4y minus 2 equals 90. So a little bit of algebra. So that will give me, let's see, 23. That would work there. Over here for x, I need to be a little bit pickier because that's going to be 2x plus 5x plus 6 equals 90. Sorry, that's a plus. It's not a 7 as it's kind of looked. So I have 7x plus 6 equals 90. So subtract 6. So 7x is going to equal 84. And then when I divide that, x is going to equal 12. So now these values, 23 for y, 12 for x, make it so that these two are 90-degree angles. By making them 90-degree angles, that makes them perpendicular. Okay, a lot of ideas here. A lot of ideas that you have to kind of kick around and kind of become familiar with. Okay, you can't rush it. Be fully aware that there's a lot of terminology here, and don't shy away from it. Spend all the time understanding kind of what they mean and how they work. Okay, so from here, you're doing your 1-5 assignment. you should be doing your Unit 1 review, which means you should be close to doing your Unit 1 test. Okay? Please take your time. Please come talk to me with questions. Thank you.